Hello everyone, welcome back to Spectrum classes. This is my part 2 video of the experiment determination of adsorption of acetic acid by charcoal. In the part 1 video, I have shown you the detailed experimental method how we perform the experiment. So here we are following the Freundlich Adsorption Isotherm to determine the concentration of the acetic acid adsorbed on the charcoal, and this experiment is very important for research purpose also to get the adsorption of dyes over the activated charcoal or different kind of charcoals which we are having, right? So first of all, I have prepared the stock solution of the acetic acid whose concentration is 3.7 normal. I'll show you the experimental part for this. So here I have taken 1 gram of charcoal, and this stock solution I have prepared by dilution method. So I have taken 20 ml of concentrated acetic acid in 100 ml measuring flask, the volume up to 100 ml of this stock solution of acetic acid. And now after this I have labeled it as acetic acid stock solution, and I titrated 10 ml of this against 0.5 normal acetic acid, and I have prepared different concentrations of acetic acid 0.5 to 0.1 normal by dilution method. In this much I have taken. So if you want to really know, then you can see in detail in the previous video, right? So by dilution method, how we are going to perform this or how we are going to prepare this concentration. So here is the formula, normality equation. 3.7 normal stock solution normality of acetic acid. X ml of this taken to prepare 0.5 normal of acetic acid in 100 ml. So how much volume I need to take? So for this 0.5 normal, I need to take 13.8 ml of this stock solution in 100 ml. Similarly, for 0.4 normal, I need to take 11.5 ml of this stock solution in 100 ml, right? And similarly, we have prepared all other acetic acids. Now we are moving to the titration part. So titration, as I have prepared 5 different concentrations. So I have to perform 10 number of titrations. One is before adsorption and the other one is after adsorption. Before adsorption is what we prepare, and after adsorption is taking 50 ml of this, I have added into the reagent bottle which is having 1 gram of activated charcoal in that, and after leaving it for 30 minutes, and in between we are shaking the bottles occasionally, and after 30 minutes I will filter it out, and that filtrate is termed as after adsorption. So first I will show you what is called before adsorption and what is called after adsorption. So here are our 0.5 to 0.1 normal acetic acid, and these are our reagent bottles which contain 1 gram of activated charcoal. I have taken 50 ml of this from bottle number, from this is before adsorption, and I have taken 50 ml of this. I have added to the reagent bottle, right? 50 ml. So this is called before adsorption, and this is called after adsorption, after leaving it for half an hour. So you get it what I am saying? So this is after adsorption in the reagent bottle. After half an hour we will filter it. Similarly we do for other bottles too. So the initial reading for the burette is 0. Final reading for the burette is 10.5. Difference between these two is 10.5. Similarly, for after adsorption, the initial burette reading is 11 ml and the final burette reading is 19.4 ml. And the subtraction of these two, or the difference of these two final to initial, is 8.4 ml. Similarly, we do all the experiment. Here you can cross check that before adsorption you have more volume consumed and after adsorption less volume consumed. Here you can see. So that is the clear cut indication that adsorption is going to be happen over there, right? Now moving forward, what we will do with these readings. Okay, so here is the concentrations before and after adsorption, which is presumed, and here is the volume of 0.5 normal NaOH consumed against 10 ml of 0.5 normal acetic acid before adsorption, and this is the volume consumed of NaOH against the 0.5 normal acetic acid after adsorption. So after adsorption the concentration changed, right? So the formula which we are going to use to determine the concentration is here. So here we are using this formula, N1V1 is equal to N2V2. So normality we need to calculate of what? Of acetic acid, which is before adsorption. So 10 ml we have taken of this acetic acid. 0.5 normal is the concentration of NaOH, and this is the volume consumed of NaOH. So first set I have kept over here. Now on calculation, this we get the concentration or the normality of acetic acid 0.5 normal before adsorption is this much and after adsorption is this much. For 0.4 normal acetic acid before adsorption is this much and after adsorption is this much. Similarly, you can see all the readings, you can check, and what you need to change, this is fixed because this is the normality of NaOH. Here volume change. This volume 10 ml we have taken every time before or after adsorption. So we are going to calculate the normality value. So here this value change in this equation and you will get the normality equation. Fine. So you come to know the normality value of the acetic acid before and after adsorption. Now coming to the next calculation. So the next calculation is how we are going to measure the concentration or the weight of acetic acid which is adsorbed, right? So to determine the weight, we have a formula. Weight is equal to normality into equivalent weight into volume divided by 1000 to convert it into the liters, right? Volume is in ml, so we convert, divide it by 1000 and we get in liters. So the unit of the weight is gram per liters, right? So what values you are going to put here? So the normality you know every time. This is the normality. So you have to change every time this value normality. Equivalent weight of acetic acid, which is 60 grams because it is having one dissociable proton, right? So 60 grams is the equivalent weight for acetic acid. Volume is the 50 ml. What 50 ml? So this 50 ml which I have taken in the measuring flask, I'm just showing you here. Here is the 50 ml. 50 ml I have taken for the adsorption, right? So according to this 50 ml, I have to calculate the weight. So I hope you understand from where this 50 ml comes. So this 50 ml is what we have taken for adsorption. If you are changing the volume, like if you are taking the 100 ml or so, you can put it here, right? Now, after solving this factor 60 into 50 divided by 1000, I will get 3 out of this, right? And this normality into 3 grams per liter. But this grams per liter, I have to convert into milligrams per liter. If I do not convert it into milligrams per liter, then what I will get? I will get 1.575. 1.260, 1.245, and here 0.975. But my ultimate goal is to get the log values. And if I get the log value of 0.975 grams, then I will get negative value. So just to avoid that negative value, I just convert it instead of grams into milligrams. Fine. So here in this manner we have calculated. So normality, say this is the normality into 3. So multiply it by 3. So 5 3s are 15. So roughly you can get the value. 4 3s are 12. So you can get the value into 1000. So this is how you can calculate the weight of acetic acid adsorbed or corresponding to this normality, right? Now our main aim is to determine the weight adsorbed on the acetic acid. So the weight adsorbed on the acetic acid is the difference between before adsorption and after adsorption. As you have seen here, before adsorption is more and after adsorption is less weight. So the difference of the weight is adsorbed over the acetic acid. So if you subtract these two values, so you will get the weight of acetic acid adsorbed on the charcoal, right? Now coming to the next, my next aim is to calculate the x upon m value. So what is m? M is the mass of the charcoal. So what mass I have taken? I have taken 1 gram of charcoal every time in each reagent bottle. So if I divide it by 1, I will get the same value, right? So x upon m is having the same value. Now the next goal is to calculate the log base 10 of x upon m. So here I have determined this. So you do not get confused. Here you have written x and here you have written x upon m. So m is 1. Actually I have taken 1 gram of charcoal. So this is how you can take the log value of this. So if you are having 3 numbers, then you will get 2 point something. 2 point something, 2 point something, 2 point something, and if you have two numbers, then you will get 1 point something. So these all are positive values. So that is why I have converted it into milligrams. Now the next goal is to get the log value of equilibrium concentration. Now the question comes, what is equilibrium concentration? So equilibrium concentration is the concentration while we are doing the adsorption, right? So some part is adsorbed, some part is remaining. So they are established an equilibrium. So the value of concentration on equilibrium is the concentration of acetic acid adsorbed after adsorption. So here are the equilibrium concentrations, right? And on taking the log of these equilibrium concentrations, we will get these values. So here is the log CE values and here are the log x upon m values. Now I am going to explain the Freundlich adsorption isotherm. So here is the formula for the Freundlich adsorption isotherm. So x upon m, x is the amount of acetic acid adsorbed on the activated charcoal. Here m is the mass of the activated charcoal onto which the acetic acid adsorbed. So in our case m is equal to 1. Here is the proportionality constant K and here is the C. C is the equilibrium concentration which I explained in my previous slide, and here 1 upon n. This is the formula for Freundlich adsorption isotherm. If I take log of both sides, then what I will get? I will get log x upon m is equal to log k plus 1 over n log CE. If you think whether it is natural log or log base 10, so you can think of in either way. So if you take log base E and you want to convert it into log base 10, so what you need to do? You need to do 2.303 log base 10 x upon m on the right hand side also, and you will cancel out. So this is the value of log base 10, right? So log base 10 x upon m is equal to log base 10 k plus 1 upon n log base 10 CE. And from here, what you will get, if you put y is equal to mx plus c, then we have m is slope and c is the intercept. So slope is what? Slope is 1 upon n and c is what? Log k is the intercept value. If we plot a graph between log x upon m versus log CE, so CE is on the x-axis and x upon m is on the y-axis, right? From here you can relate. And from that graph, from the slope value, we will be evaluated this 1 upon n and this from the intercept log k, we can evaluate, right? Now I am showing you here. Now the plot which we have drawn in the Microsoft Excel is here. And from here, if I evaluate the slope and the intercept, what I need to do? I need to use this. Here is the slope value. Here is the value of the slope, 0.761. After extrapolating the graph or this curve, I will get the value of the intercept. So intercept is equal to log k, which is equal to 0.16. And from here, we can evaluate the value of n and k, right? So here is the value of n and k. And our data follows the Freundlich adsorption isotherm, as we get the straight line here between the log x upon m and log ce value. I hope you find this video useful. So please do not forget to subscribe the channel, as number of subscribers are very less. If you like this video, please give me a thumbs up, share with your friends. Thank you all. Thanks for watching.